Hello everybody. Today we are going to look at the normal distribution, which is the beginning of chapter 3 and which will pretty much lead us into the rest of the material for the course. So today we're going to look at normal distribution worksheet 1, how to find probabilities using our normal distribution table. So the paper that you're going to want to have handy, is our normal distribution curve, which is posted in your work. There's a negative side and a positive side. So you want to make sure that you have that table E when you're working on these. Right. So in the first problem, it's saying what is the probability that we could have a z-score between 0 and 1.58. So if I was going to draw a picture of this, in my normal curve, I know 0 is always the center and a z-score of 1.58. So I know this probability. I know half the curve is always 50%. So I know my probability is going to be less than 50%. So what I'm going to do is I'm going to look up 1.58 first. So on my z-score table, the way we look this up is we go to 1.5 and then we go all the way over to 0.08. So that would be the value 1.58, and that's an area of 0.9429. Now whenever you look at this area, that is always the area to the left. So what we're saying is 0.9429 represents the area from here all the way to the end. Now we know that half the curve is 50%. And again, on your table, a z-score of 0 is 50%. So this area is 50%. So the area under the curve, to figure out my shaded part, I'm going to take 9429 and subtract that 0.5. And that area under the curve, what that represents is the probability, the percentage. 44.29%, that's the probability that you would have a score that falls between 0 and 1.58. So that's how we're going to use our normal distribution table to find probabilities. Now if we look at number 5. Number 5 says, what's the probability that we're going to be between a z-score of negative 0.91 to a positive 1.41? So I'm going to draw that picture first. I know again 0 is the middle. 1.41 is going to be over here. Negative 0.91 is going to be there. What's the probability we're going to fall between those two? So if I look at my table, 1.4 to 1 is 0.9207. Again, that is the area to the left, from here all the way down to the left. If I want to find a z-score of a negative value, make sure you're looking at the negative values. Negative 0.9 and then over to 1 is going to be 0.1814. So again, I want to know just this shaded area. I don't want to know that 0.1814, so that's what I have to subtract away. So when I subtract that away, the probability that I'm going to be between those two z-scores is very good. It's about a 73, almost a 74% chance. So that's how we find probabilities. That's how we use the curve. I'm going to do 2 more examples. I'm going to do example 3 on the paper, which says find the probability that z is less than or equal to 0.87. So 0.87 less than or equal to means I shade to the left. So anytime we want to find the area to the left, we just look up the value in the table. So 0.87 is going to be 0.8078. Okay, when I look that up. Okay, again, I find 0.8, I go across till I get to 0.7. Okay, 8078, that's my answer. Okay, that's the area to the left. Less than is always the area to the left. So that would be my probability. Now, if we look at number 4, the question it's asking is, what's the probability that z is greater than 2.94? Okay, 2.94 is going to be way over here. The probability I'm going to be greater than, okay, I know that that's going to be a very small probability. So when you look up 2.94, okay, you get a large number there. You get 0.9984. But remember, anytime you look something up in the table, it's the area to the left. That's why on that picture of the table, they show you the shaded part, the area to the left. So we know that the normal distribution, the whole curve is 100%. So if I subtract from 1, the probability that you're going to score greater than 2.94 standard deviations is extremely small. Okay, less than 1% chance, as the picture tells us. So drawing the picture helps you figure out the probability. So that's what you have to do in part 1, is find probabilities. Now we're going to take it a step farther in part 2. Okay. In part 2, what they are asking us for is now a little bit more context of the problem. Okay, so in part 2, what we know is that the mean is 100. Okay, and we know the standard deviation is 10. And what we want to find out in number 1 is what's the probability that x bar is going to be less than 112. So our first step is to find the z-score. So if I do 112 minus 100 divided by 10, okay, that's going to be 12 divided by 10, or a z-score of 1.2. So 112 is going to represent a z-score of 1.2. And we want to know what's the probability that we're going to be less than that. Okay. Now that you have it in this z-score form, so what I did is I took an actual problem, converted it to a z-score. Now we're just doing what we did in step 1. We're going to look on our table at 1.2. Okay, 1.2 is 0.8849. So the probability that you're going to score less than 112 based on this distribution is very good. It's about an 88% chance. Okay, so we're converting an actual score to a z-score so that we can find its probability using our table. We'll do one more in that group. If we look at number 6, okay, the probability that we're going to be between 81 and 89.5. So again, we know the mean is 100. What's the probability you're going to fall between 81 and 89.5? And notice I put both those values on the left-hand side because they're less than 100. So we have to find two z-scores. So we're going to use our z-score formula twice. We're going to say 81 minus 100 divided by 10. And we're also going to say 89.5 minus 100 divided by 10. So this is going to be a negative 19 divided by 10, which is a negative 1.9. And over here, if we subtract, it's going to be negative 10.5 divided by 10. So that z-score is going to be a negative 1.05. Once we get those two z-scores, okay, once we get these two z-scores, okay, then we look them up in the table. So I'm going to look up negative 1.05 first. So I'm going to go on the negative side. Okay, negative 1.0, and then go over to 05. It's 0.1469. And I'm going to look up negative 1.9, and that's going to be 0.0287. Okay, so again, from here to there is 0.1469. From here to here is 0.0287. I don't want this part of the probability. I want to know between 81 and 89. So therefore, I have to subtract 0.287 from 1469. And when I do that, what I'm going to end up with is about 11.82% chance of that happening. Okay, small percentage that the score is going to be between those two values. Okay, so that's how we answer those type of questions in part 2. Okay, in part 3, okay, now they're asking you to do kind of the reverse, right? So in part 3, it says the area to the left of Z is 0.6591. So if they say the area to the left, I'm going to start at the left. I know the area to the left from here, that's 0.5. Well, so 0.6591. Okay, what Z-score is that going to represent, basically, if the area to the left of Z is 0.6591? So when you go to look for a Z-score, now you're doing the opposite. You're looking in the body of the table. We're looking for what value is closest to 6591. And these numbers go in order. 6517, 6554, 6591 is right there. So now I go back. I go, all right, what's the Z-score? It's 0.41. So again, if you had a Z-score of 0.41, if you look that up in your table, okay, 0.41, well, the area was 0.6591, and that's what we want to know. Okay, area to the left was 6591. Now, if we do an area to the right, okay, the area to the right is 0.4168, so I'm going to start from the right-hand side. And because it's not greater than 50%, I know it's going to fall, okay, on this side. Okay, again, I'm still trying to figure out what is the Z-score. Remember, when you want to find a Z-score, what you want to find out is the area to the left. They told me the area to the right was 0.4168. So if I do 1 minus that, if I do 1 minus 0.4168, that's going to be 0.5832. Okay, these two numbers have to add up to 100%. That's my area to the left. So when I go to look up 5832 in my table, okay, it's right there. Okay, Z-score of 0.21. Okay, now sometimes when you go to look up a value, it won't be there on the table. For example, if I was trying to look up 6953, okay, well 6950 is the closest, so I would go to that Z-score. If I was trying to look up 6986, then I would use this one. So you always go to the one closer when you're in between two scores. Okay, it's not exactly there. Okay. And then the last thing we're going to talk about in part 4 is a cutoff score. Okay. So in this problem, they're telling you that the mean is 14 and the standard deviation is 4. Okay, and in number 4, in part 4, it says this score cuts off the top 20% of scores. Okay, so everybody agrees that the top 20% would be here. So what we're trying to figure out is, what is that actual score? Okay, so if you think about your formula, you have 4 pieces in your formula. Okay, they have to give you information to find 3 of them. Okay, they told me the mean was 14. They told me the standard deviation was 4. We're trying to figure out the actual score. So the missing piece they must have given us enough information to find is the z-score. Okay, so think about this. Okay, top 20% falls here, which means the area to the left would be the bottom 80%. Okay, I can find a z-score if I know the area to the left. So go back to your table. I'm going to look for 800. Okay, I'm not going to find 800, but I am going to find 7995. I'm going to find 8023. Well, this value is the closest, so I'm going to take this value to find the z-score. So if I go across, it's 0.8, and if I go up, it's 0.04. So 0.84 is going to be that z-score. Now you can solve this problem. Okay. So when you are given a percentage, like top 20%, bottom 10%, middle 50%, that's going to allow you to find the z-score, and therefore you can find out what the cutoff score is now. So algebraically, if I solve this, 0.84 times 4, and then add 14, x bar is going to equal 17.36. So what that means is that for this distribution, if your mean was 14 and your standard deviation was 4, if you score a 17.36 or better, you're going to be in the top 20%. Okay, and again, a lot of places use this on placement tests. Okay, you have to get this score to get a raise. You have to get this score to get this promotion. You have to be in the top percentage to get into this school. Okay, that's what a cutoff score is. So when you see the word cutoff score, you are solving for x bar. You're solving for that sample mean. That's what a cutoff score is. Okay, so that is our introduction to the normal distribution, and hopefully that video will help you solve those problems.